Okay, so the first part of our today's lesson is dividing rational expressions. So we are gonna start off with that. Dividing rational expression, that's not like so different from multiplying rational expression in the sense that you do the same thing. Like moving down, you actually do the same thing. So what am I even talking about? Okay, so fancy terms, dividend, right? You hear about dividend, and then there's also divisor. Well, they're nothing fancy really. Dividend is actually, like it says in the parentheses, the first fraction, and divisor is your second fraction. So what you are supposed to do when you're dividing two rational expressions, I'm not sure, but in middle school there was something that I learned as KCF. Sounds like KFC, but it's not. It's keep, change, flip. So what I mean by that is you keep the first rational expression that you have. So you keep the first fraction, you change the sign. So if it was division, right, you're supposed to make it multiplication, and you flip the other fraction. So you keep it, change it, flip it, right? So what is exactly written in here? It says that when you are trying to divide two, so I'm starting off with like numbers first, right, before we move on to algebraic expressions. And then it tells me that when I'm trying to divide two numerical fractions, I have to multiply the dividend, which is the first fraction, with by the reciprocal of the divisor. So I multiply the first fraction by the reciprocal, which is like when you flip the fraction, it becomes reciprocal with the reciprocal of the second one, okay? So it's just the same thing. You keep it, change it, flip it, okay? So you keep it, change it, flip it. Once you do that, you kind of look for common factors. Just simplify it. You guys should know how to simplify rational expressions by now. You look for common factors, cancel them out. Whatever you are left with, you just multiply them across, and then you have your answer, okay? So this is pretty much 2 comes down as to be 2 because 2 cannot be like, further factored. But then for 9, you can factor it as 3 times 3. 3 comes down as 3, and because 3 is a prime number, and 8 comes down to be 4 times 2. And then you kind of look for common factors. You have a 3 here, you have a 3 here, you cancel them out. You have a 2 here, you have a 2 here, you cancel them out. I color coded them so it's easier to follow. And at the top, you're left with 1 here, 1 here, you multiply across, you get 12. And at the bottom, you have 3 times 4, you have 1 here, and then you have 1 here, you multiply that, you get 1. And at the bottom, you have 3 times 4 gives you 12. So that is your final answer. It cannot be simplified any further. As long as your answer can be factored further, that is not your answer, because you are supposed to leave your answer in the simplest form. You have to leave it in the form that it cannot be further factored. Okay? That was just the starting. And so now we are actually trying to like divide rational expressions. So we will try that the same method, right? The same way, but we are going to try that with an algebraic expression, right? So now we have, with the numbers, we have variables, we have exponents, fancy stuff. Let's get started, okay? It's the same thing that I just said. You keep the first fraction, right? So you keep it. You change the sign, so division becomes multiplication, and you flip it. So 9x goes to the bottom, and 10x comes to the top, right? So you flip it. So now that you did it, you can now multiply them, okay? You can only multiply them across. Do not cross multiply rational expressions. You can cross multiply rational equations, right? So when you have equations like that, you can cross multiply, but you can only multiply across expressions, okay? So now that we did that, we are supposed to follow our good old friend, which is factoring, right? We have to factor the top, factor the bottom. Let's see how that goes. Okay, so at the top, we have 3x to the 4th. So now I know that 3 is a prime number, so I'm just going to bring it down there. I'm not going to do anything to it because it cannot be factored any further. And then I'm going to, I broke down x to the 4th here as like x times x to the 3. If you do not want to do that, you don't have to. But it was just for you to kind of like see and follow along. And then for 4, I broke it down into 2 times 2. For 10, I broke it down into 2 times 5. For 9x, I broke it down into 3 times 3 because 3 and 3 are factors of 9, and I had the x right there. You guys don't have to do all of this part, right? Because that was just for me to kind of like explain it to you. You can directly come from here to your answer, right? So then you look for common factors. What are your common factors? You have 3 at the top, 3 at the bottom, they cancel out. X here, they cancel out. You have 2 here, they cancel out. And there you go, right? Once you're done canceling out your common denominators, you are supposed to multiply across and you should get your answer. In here, you just have left x to the third power, have 5, you multiply across, you get 5x to the third. At the bottom, you have 2, 3, 3 times 2 gives you 6, and that is your final answer. It cannot be simplified any further. Welcome, Amina. I was actually hi. I'm actually like talking about dividing rational fractions. Rational expressions. So when you were trying to like divide, as I was telling before, when you're trying to divide rational expressions, it's the exact same thing as multiplying, which is why you learn multiplying before you learn about dividing rational expressions. So you basically, what you do is like you keep it, you change the sign, you flip the other fraction, right? So that is like, when I say flip, the fancier mathematical term is like the reciprocal. So the thing that you're supposed to do is like, so like for this problem, right, which is written here, you keep the first fraction like it was. So I brought it down like that. I changed the division sign into multiplication, and then I flipped it. When I flipped it, the 10 went to the top, and 9x came to the bottom. Right? Once you do that, it is the same thing as multiplying rational expressions. Okay. I believe you were not there when we talked about multiplying rational expressions. So I'm just gonna go over with you really quick as to how you do that. When you are trying to multiply rational expressions, you can multiply across, or you can factor and then try to like, get rid of the common terms. So when you do that too, like, so what I did in here was like I factored, right? I factored the top and I factored the bottom. When I factor the top, 3 comes down to be 3 because it's a prime number. X to the fourth is like x times x to the third. You do not have to do it. You can just leave it as x to the fourth and can simplify it from there by just I wrote it down to like show you guys. So then you have 4 for the two factors are 2 times 2. So I broke it down like that. I broke 10 into 2 times 5 and 9x as 3 times 3. And then I had the x in there. And then I looked for common terms, okay? 3, they're common terms, so they cancel out. X, they're common terms, so they cancel out. And I have 2, another 2 in here, they cancel out. So whatever you have left with, which is what I have in here, you multiply across. 5 times x to the third gives me 5x to the third, and 3 times 2 gives me 6, and that is my final answer because it cannot be factored any further. Any questions so far? No? I'll take that as a no. So if you guys don't have any questions, I know that questions will come up when we do practice problems, which is why we are going to do practice problems next, okay? Try to do these 2 practice problems and come up with questions, request for help, ask for help, and I will be here to help you. I'm going to give you guys about 4 minutes to practice these 2 problems, okay? So looking at the first problem, right? Look at the first fraction, or look at the first fraction, right? The fractional expression. You keep it, change the sign, flip this part, and then you have turned this expression into a multiplying rational expression, and then you can get your way through from there, okay? And when you are trying to multiply rational expressions, do something, you factor, cancel out common terms, and then you have your answer. For the first one, you don't actually have to factor, but if you want, you can, because they are like mostly, not mostly, they're all like monomials. But for the second one, you have to factor. There is no other way you can get rid of the common terms. private message me the answer if you can't figure it out. And please, please, please ask me a question, ask me help. If you are stuck, if you're confused, I will be here to help you. Um, try it one more time, Amina. Okay, so oh, it's okay, Maggie. Okay, so we are gonna go over it together. Not a problem. So I keep the first fraction, right? I changed the sign, so now it's a multiplication, and now I flip the second fraction, right? So this is my dividend. So I keep the dividend, flip the sign, and I mean change the sign, and then flip the divisor. Right, so now what do? I look for common terms. Oh, Amina, that was actually correct for the first one. I kind of like read it wrong. I'm sorry. That
Really?
is correct for the. Sorry.
Really?
That was yeah, that was correct for the first one. So now you look for common terms, right? Well, let's go for the variables first because we kind of know how to like simplify numerical fractions at this point. So let's go for variables first, okay? I see x to the second here and x to the fifth here. So then I know that there are two. Okay, so yesterday I was talking about it. This, when you do this, right? So there's actually exponential rules, right? So when you are like dividing variables that have so when you're dividing variables with exponents, right? You look for the base. If they have the same base, you keep the base, you subtract the exponent, and then you get x to the third, right? So that is what I'm gonna get when I simplify this, right? But okay, if you do not know about the rules of exponents, you don't have to worry about that because you know that if you have 5x's at the top and if you have 2x's at the bottom, you know that you can cancel these two from the top and these two from the bottom. So then that's what you do, and you're left with 3x's. Well, 3x's, they multiply to be what? X to the third, right? So either way you do it, you should get x to the third as your answer, right? So that is what I'm going to put in there. So when I cancel x squared and x to the fifth, I should be left with x to the third, right? Because that's what we got. And then now we are like down to only numbers. So like you have six, I mean, you have three, you have six, you can cancel them out. 3 divided by 3 is 1. 6 divided by 3 is 2, right? And now you see 5 and 15 and then 10. You can divide both of them by 5 because 5 is their GCF. Once you figure out the GCF, you just divide each of the terms using the GCF. So you divide this by the GCF, which is 5, and you get 2. 10 divided by 5 is 2. You divide this by 5, and you get what? 3, right? So now whatever you are left with, you multiply them across. Please do not cross multiply, but multiply across, okay? You have x to the third here, and you have 1 here. You have 2 here. You have another 2 here. Yeah? So then I just multiply across, and I get x to the third over 4. I'm sorry, there was a 3 left in here. Okay? So then that multiplies to be 3x to the third over 4. Right? And that is your final answer because it cannot be simplified any further. Any questions on the first one? If you guys don't have any questions, work on the second one. Okay, let's work on the second one together, okay? What do I have to do? What I have to do is, I see that the first one, right, it is kind of like, so the top has a trinomial, even the bottom has a trinomial, but I can't just cancel out the x squares like that. I can't cancel 16 and 8 and write like 2. I can't do that because they're all attached to each other. They're all in one expression, okay? So if it's like that, I cannot just cancel out individual terms. I can't do that. That is not permissible, okay? So then what I can do rather is I can factor. So then let's factor. How do you factor trinomials? Oh, even before I do that, I should have changed my expression that I have in here into a multiplication one, okay? So I keep the first fraction. So whatever I have, I keep it like that. I'm just not gonna rewrite it again. And I change my sign into multiplication, and then I flip the other fraction. So x plus 4, it goes at the bottom, and 1 comes, x plus 4 goes at the top, and 1 comes at the bottom. You can just write it as x plus 4. You do not have to write that as a fraction because when you have 1 in the denominator, it doesn't really matter, okay? So then how do you factor trinomials?
Is it like x plus 8 and then x plus 2?
Let's verify. Does x plus 2 give you 10? Does 8 plus 2 give you 10? Yes, it does. Does 8 times 2 give you 16? Yes, it does, right?
Mm-hmm.
So then, yes, those are actually your two numbers. I was gonna actually do it, but then Amina already told me the answer, which is great. I was gonna ask you guys that what two numbers if you add you get 10, and what two numbers if you multiply you get 16. Well, the first step that you should be doing is finding the factors of 16. Okay, what are the factors of 16? 1 times 16, 2 times 8. And while you're finding the factors, do not just list all the factors because then it's just going to be a lot of work for you. While you are doing it, just keep in mind that you have to ask yourself, can I modify these two numbers to get them to be added to negative 10, right? So you can make both of them negatives, you can make one of them negative, the other one positive, and then try to add them and then come up with 10. Is there any way you can ever make 1 and 16 to be added to 10? No, you can't. If you do negative 1 plus 16, that is never going to add to 10. Negative 16 plus 1, nope. If you subtract both of them, so like negative 1 minus 16, that is also never going to give you 10. So the first one actually doesn't work out. Now ask yourself about the second one. You have 2, you have 8. Can you modify 2 and 8? So by modify, I mean, can you change the signs of 2 and 8 to make them added to 10? I think you can, right? How can you do that? Added to 10. Well, if you keep both of them as positive, so if I do 8 plus 2, I should get 10, right? And 8 plus 2 I already know gives me 16. 8 times 2 already gives me 16 because I already found that as my factor. That was already my factor of 16, right? So that's how you kind of figure out the two numbers that will add to your middle coefficient and multiply to your constant. So now let's do the same thing for the bottom. I know that for both of the factors, right, x is the first term that comes into the parentheses, okay? Just remember that. And now let's figure that out. So what are the two numbers that will add to 6 and multiply to 8? Okay, so Amina just told me 4 and 2. Yes, 4 and 2, they do add up to 6. So check 4 and 2. They also multiply to be 8. So check. Then those are my two numbers that I should be putting as my second term of the factors. Okay, so once you're done factoring the top and done factoring the bottom, you are done with your first fraction. Let's move on to the second fraction. Do I have to do anything to the second fraction? What I'm asking you is that do I have to factor the second fraction? Is it even factorable? Thank you guys. No, it's not factorable, so I just leave it like that. So now I look for common terms, right? So I go from here, I start off with my first binomial factor. So then I ask myself, do I see 8 plus x plus 8 anywhere in this expression other than the place it originally is? So are there any 8x plus 8 in this fraction? No, right? So it does not have a common factor. Now you ask yourself about x plus 2. Do you see any other x plus 2s?
Yeah, at the top and at the bottom.
Yep, I see it too. Now you ask yourself about x plus 4. Do you see any other x plus 4 in this expression?
It's in the second expression, I guess, like the.
Yep.
The
and you can, okay, so what you can do is like, okay, you can find common factors like, you can find common factors like top, you can find common factors like top, bottom. You can't find common factors across, because if you do that, you can't cancel them out. You can only cancel stuff out like top, bottom, and then if you have something like diagonally on the other side, you can cancel them out, but you can never cancel stuff out across. So do not look for common factors across. Okay? Alrighty, so now that we have figured out our common factors, we do the most satisfying thing, which is canceling out. This can't
satisfying.
I find that to be like oddly satisfying, because you know, I'm like like crossing them out, like drawing that line across. That's like so satisfying. Hold on. Okay, so this was, I have common factors for x plus 2. So boom, boom, cancel them out. X plus 4, I cancel them out. And whatever I'm left with, I multiply that across. So now whatever you're left with, you can multiply that across. So like, you know, so vertically you can multiply, yeah, that is vertical. Yeah. No, that is horizontally. You multiply them horizontally, right? So whatever you have left, I have x plus 8 in here, and I have 1 in here. So x plus 8 times 1 gives me x plus 8. And at the bottom, I have nothing else except 1. And I can write it, or I can't, because if you have a 1 in the denominator, it doesn't really count. It simplifies to be only the numerator. So that is my simplified answer. That cannot be simplified any further. All right, do we have any questions? Any questions, comments, concerns? If not, let's move on. What do we have next? Oh, I have another practice problem actually, so let's try this one together. Oh, no. You guys want to try it together, or you guys want to try it individually first?
Individually?
Yeah, sure. So I'll give you about 2 minutes to practice this problem, and then we are going to go over it together. Please, please, please let me know if you have any questions, if you are stuck, if you're confused. The only way that I can be able to help you is through you asking me questions. Okay, so please, please, please reach out for help. There are actually 2 of us in here that are always ready to help you in any possible way, okay? So please ask us questions. Private message me the answer if you are able to figure it out. If not, then we will go over it together. Or I can like help you out. Try that one more time, Amina. It's totally okay. Oh my God, do not be sad. You are trying. I mean, that's all I need from you. As long as you're trying, you are getting it right. Let me ask you something else. What are the different kinds of factoring that we learned from the beginning? Like, I don't know if you remember or not, but I'll tell you. We started off with GCF. That is the most basic type of factoring, right? So if you cannot do anything to an expression that is factorable, you should at least be able to do GCF. Okay.
No, so
So let's start.
GCF and then multiply.
Yes. If you take out the GCF, you should be able to observe something. It should look like something else that we are trying to make it look like. So once you factor out the GCF, whatever you have left with, that should look like you get the right dots.
Okay, I get it.
That is correct. Alright, so I'm gonna go over this question. Okay, so what we are supposed to do is keep, change, flip. So we are supposed to keep our dividend, change our sign to multiplication, and then flip the divisor. Okay, so I'll write that down here. Multiplication, flip it, so my denominator comes to the top and my top goes to the bottom. I can write the one there, or I can just not do it. So now I'm trying to find the I'm trying to factor the top and the bottom. Well, the top is not, I can't really factor it because it's 8. If I mean I can actually factor. I can write the factors of 8 in there, but I'm not gonna do it. I'm just gonna keep it as 8. So let's factor the GCF. What is the GCF of this expression in here?
4n.
Yep. I know that the GCF has to have a number because both of my terms have a number. So what is the GCF of 4 and 16? Well, the GCF of 4 and 16 is 4 because that's the greatest number that goes evenly in between those two numbers. And then I also know that my GCF is going to have a variable to it because both of my terms have the variable. And this is something that I told yesterday. When you have when you have variables with different exponents, so let's say you have n to the second power, n to the third power, and n to the fifth power, what is your GCF? Well, when you have variables with exponents, different exponents, and you are asked to find the GCF, you always pick the variable with the lowest exponent, right? So n to the second power is going to be your GCF, right? So even though it says greatest common factor, I know the word greatest, and I just told you about the lowest exponent. Well, the word has common, so you have to pick something that is common between all the things that you have in here, right? So between n to, so let's just look at the exponents, right? So between 2, 3, 5, I kind of have 2 in common, in between all of these exponents, right? But I don't have n to the third, right? That is not a common one because n to the third and n to the second power has only 2 n's. How am I gonna find 3 n's in there? So I can't pick it. You can only pick the exponent with the lowest power because that is your greatest common factor. Okay, so when you have n squared and then n, your GCF is gonna be so when you do that, right? So you factor out 4n, right? Okay, so 4n squared divided by 4n, that actually gives you n because the 4's cancel out, and you have n squared at the top and at the bottom, so you can cancel out the n, and you're just left with n, right? Minus, and then 16n divided by 4n. Well, the n's cancel out, right? The n's cancel out, and then you are just left with what? You are just left with 4 times, 16 divided by 4 is just 4. can't really do dots. You could have do dots if there was a square here, but then the expression doesn't have a square in there because the GCF takes the n out, so then you are just left with one n inside the parentheses. Yeah, so you can't do dots for that. Okay, so I wrote my fractions, right? So then after I'm done factoring the top, the bottom of both of the fractions, I wrote them down, and now I look for common factors. Okay, so I asked myself, do I see, okay, so for 8, that's a number, I'm just gonna leave it out. So now let's go for the expressions first, okay? So the binomial that I have in here is n minus 4. Do I see any other n minus 4s? Yes, I do. It's so evident, it's right there, right? And I have 8 at top and I have 4 at bottom. I know that between the GCF of 8 and 4 is 4. So I'm gonna divide both of them using 4. 4 divided by 4 is 1. 8 divided by 4 gives you 2. That's what I wrote in top, and that should be it. There is nothing else. Oh, the satisfying thing.
Cutting out.
Yep. Whoop, whoop. So then I have nothing else to cancel because I do not have any more common factors. And when I do that, whatever I have left, right, I just multiply them across. So 2 from the top of the first fraction and nothing other than 1, right? Other than 1 from the top of the second fraction. So I multiply them together, I get 2. And then I have n. I have nothing else at the bottom of the other fraction other than 1. So I just multiply across. So n times 1 gives me n. 2 over n is your final answer. You cannot further factor that. So that is the simplest form for that, okay? Any questions? I'll take that as a no. So I have a video for you guys, and the video, it goes over dividing rational expressions. So if you guys feel like you need to watch it, please watch it in your own time. It is gonna help you a lot, okay? Okay, so we're also gonna learn about adding and subtracting rational expressions today, but it's gonna be easier because we're just gonna learn about adding and subtracting rational expression with the same denominator. When it's different denominator, it gets a little complicated and it gets messy. But for now, we are just going to learn about same denominator and how to add and subtract rational expressions. Okay, so how do we do that, right? We all learn about adding and subtracting rational expression with the same denominator in middle schools, right? We did it. So if we have the same denominator, we bring down the denominator because guess what? The common factor is 5, right? If you have 5 and 5, another common factor is GCF. GCF of 5 and 5 is 5. And then whatever you have at the top, you just subtract it, right? I apologize. So this was actually, it cut off from the bottom. But then that's actually 4 minus 1 is 3. And then 5, you bring down the 5. You cannot simplify that fraction anymore. So that is your answer. That's how you actually do numerical. That's how you simplify numerical fractions. You subtract numerical fractions, okay? And then when it comes to doing algebraically, right, it's exactly the same thing, but instead of just numbers, you have variables with them, right? So what is the GCF of x plus 2 and x plus 2? Well, the GCF is x plus 2 because if you have the same denominator, you can just skip all of this, right, and then jump in here, right? If you have the same denominator, you bring down the denominator and then you add whatever you have on the top. So you have 7a plus 3. I brought that down here. And then I added that, right? I added that to 2a minus 1, right? So then once I do that, I have only one fraction, right? I simplified 2 fractions to be into 1 fraction. So now I look for like terms, right? What are my like terms? In order for something to be the like terms, they have to have the same variable with the same exponent. Then let's look for a, the terms that have a's in them. 7a, 2a, I combine them. 7a plus 2a gives me 9a. And I combine the numbers because they don't have any variables, so they're like terms. 3 minus 1 gives me 2, which is what I wrote in here. And then a plus 2 comes down to be as a plus 2. You cannot You cannot simplify that fraction anymore, so that is your final answer. Any questions so far? These are like easy stuff, okay? All right, so now comes to subtraction. It's the same thing. If you have the same denominator, you can jump from there to here, right? So if you have the same denominator, well, for this one, you kind of have to like look at this step. So you bring down the GCF, which is like the GCF of b squared, and then b squared is just b squared because they're the same thing. And then you bring down whatever you have at the top, right, of your first fraction. You bring that down, and now there's something that you have to do. Because it is subtraction, you have to change the sign of the top of your second fraction. The numerator is going to have like a different sign then, right? Because if when you are subtracting, when it was adding, right, it doesn't really make a difference, because when it, okay, so when it was adding, right, so if it was like plus 4 minus b, you can just write that as like 4 minus b, right? Because it doesn't really make a difference, right? But when it's like subtraction, when I do this, right, I'm telling you that there's a negative one that needs to be distributed into the first term as well as the second term. So then negative 1 times 4 gives you negative 4, and negative 1 times negative b actually gives you positive b, right? So you guys see how like the sign changes when I have a subtraction in front of the parentheses. So whatever signs you have inside the parentheses, that just becomes the opposite. So then, which is what I wrote in here, b plus 1 stays the same, and then negative 4 plus b is what I wrote in here, right? I wrote negative 4 plus b, and then I simplified it. I looked for like terms. Well, then what are my like terms? B plus b, so b plus b gives me 2b, and then 1 minus 4. So what is 1 minus 4 give me? That gives me negative 3, right? So then I simplified the top, I put it here, and then for the bottom, it's just whatever you had as a denominator that is going to come down like that. You cannot simplify this fraction anymore. If it is, if you can't simplify it, you are supposed to simplify it. Are we down to do some practice problems?
Oh my god.
Is that a yes or no?
I'll try.
Okay, it's not that hard. Look, they have the same denominators. As long as they have the same denominators, you bring down the denominator, and then if there are like two fractions added together, you add the numerators, you add the top. And if it's like you are subtracting two rational expressions, you subtract the top. That's it. It's simple. It's not that bad. I can work on these two problems together. Like we can work like together. You guys want to work together? Or you guys want to try on your own first?
Let's try like one time.
Okay, yeah, sure. I mean, I can wait. Ask me questions if you're confused, if you're stuck, if you don't have any clue at all, please ask me questions. That is correct, Amina, for the first one. See, you were scared. I mean, these are easy problems. Already, since Amina is done and Maggie does not have a pen or pencil with her, I'm just going to do this problem, okay? So I see I have x minus 1, they have the same denominator. If they have the same denominator, the GCF is just going to be the denominator, which is x minus 1. And now I bring whatever was in the top down here. So x plus 5 comes down to x plus 5. And then I'm adding them, so plus 2x minus 3, right? So then once I have that, I look for like terms, combine like terms. So I have x, 2x, plus 2x actually. They are my like terms, and I have another pair of like terms, which is plus 5 and minus 3. They're my like terms. Okay, so I just combine my like terms. Let's combine. What is x plus 2x? Well, x plus 2x is just 3x. And what is 5 minus 3? Well, 5 minus 3 is 2, and that's positive 2. That is that. And I just bring my denominator down like it was there. And this fraction cannot be simplified any further. So that is my final answer. Okay, let's work on the second problem then. Okay. Interesting. I mean, we are going to work on the second problem together. So let's just see what happened. Okay. This is actually a harder problem, even though I said that, like rational expressions that have the same denominator, it's easier to combine them. It's actually a harder one because it's being subtracted. And when you subtract, you have to change the sign of your of the preceding, I would say in this case, binomial. And then let's work on it together. Okay. I have the same denominator, so I'm going to bring down my denominator because that is my GCF. And then I bring down whatever I had on the top, but because it's a subtraction, I'm going to put the subtraction sign in here, put a parenthesis, and bring down my top of the second fraction, my numerator of the second fraction, right? So once I do that, I have to simplify the top first before I combine the like terms. Let's simplify. So there is a negative 1 in here. I have to distribute that negative 1 into 5x. I have to distribute this negative 1 into negative 2, right? So when I'm telling you to distribute, you have to multiply them together, right? So what happens when you multiply negative 1 and 5x? You guessed it right, it's negative 5x. And if you multiply negative 1 and negative 2, you should get positive 2. So that is actually your top of your simplified rational expression. And then the denominator just comes out to be as it was, 2x. Now is the time for you to combine like terms. Let's identify the like terms first. Well, I see x here, and I have negative 5x. They're my like terms because they both have the same variable with the same exponent. And then I have 1 here, and I have 2 here, positive 2, right? So I'm going to combine them. Let's combine them. So x plus 2, x minus 5x actually gives you negative 4x. Right? Because x has like 1 in front of it. So 1 minus 5 gives you negative 4, and then the x just comes down, right? And then 1 plus 2 gives you 3. And then you have your denominator down there. So whatever you had in here, that comes down in here. This fraction cannot be simplified any further, so this is what your final answer should be. I think what went wrong, Amina, was the fact that you had to distribute the negative sign. So whatever was there, you had to distribute it, right? So always remember, always remember, if you have a negative sign, right? So if there are like two, okay, so let's do this. If you have like two rational expressions that are being subtracted together, right? It doesn't matter if they have the same numerator or denominator or not. Always remember, whatever comes after, right, the negative sign, right? So in this case, it was the binomial, the sign is going to change. The positive 5x becomes negative 5x, and negative 2 becomes positive 2. That would apply in here too. If this was not plus, if it was minus, that would change to negative 2x plus 3. This thing would change into that, right? You guys see how it's like plus 2x minus 3, whatever it originally was in here. But if it was subtraction instead of addition, it would change it. It would become the opposite of what it was originally. Okay? Any questions? So that is it about today's lesson. So do you guys have any questions, any concerns, any points of confusion with whatever we did today?
No.
All right, so if you guys don't have any questions, that's it. I'm gonna see all of you next Friday.
Okay, bye. Have a nice day.
You too.